Next, we'll talk about findings and incidents, and in particular, we're going to talk about the classification of the general information. This is only 3 slides, but they're heavy slides, right? And what I'm going to do is I'm also going to be switching back and forth between the slides and the no-name platform to show you a few things, okay? All right, so let's start with data custom, okay? Customs should be under posture because they are reported as posture findings, but I find them to be more closely related to data because they're both user defined. Okay, they're both user defined. They depend on live traffic, um, data loss prevention for data, in order to identify data types that should not be communicated back and forth between your APIs. And custom, these are based upon the API metadata, right? And that you, as a user, you have described as undesirable, right? What do I mean by that? I mean, as a company, as an organization, you have a best practice that says no API should be without any authentication, right? Should be unauthenticated. So you can build a custom policy to capture all that. In fact, we actually did exactly that during our NS201. Okay. Now, if you want to see where these are, where you can set them up, I'm going to go to the no-name platform. Custom policies, they're set up under the APIs page in the inventory. These are all the different metadata. And in fact, you have many columns that are not even present, right? Tons and tons of metadata. So you can build a filter. You can build a filter for any one of these. As soon as you have the filter, then you can go ahead and create a policy, a custom policy. Okay. The custom policy one is created. It can be managed under settings, policies, custom policies. This is where you're going to find them. Okay. Data policies are tied in to the data types. So you first need to set up the data types if they're not already there. Once you set up the data types, now you can go and create your data policy that pretty much capture information that should not be communicated back and forth between your APIs. Okay, between the users and the APIs, that is. All right, so that's one. The next one, we'll talk about Recon. And again, Recon is fairly recent. We just talked about it last in the previous section. And again, it's a simulation in order to identify vulnerabilities to reconnaissance phase attacks, probes, and so on. They're domain based. That means you need to tell your no name context, probably from customer success, which domains would you like us to scan for vulnerabilities. There is a data entry. We do that. That is no name security professional will do the data entry. And then we're going to discover subdomains and we're going to scan for forbidden data, sensitive data under the domains and subdomains we have discovered. Okay. Most of the scans are passive, right? That the recon service performs, and very low intensity active scans. What do I mean by that? A passive scan is something that uses a third party, not the third, yeah, it uses an indirect way. There you go. It uses an indirect way of accessing API related data, right? That's what a passive scan is. For example, you have open to the internet API documentation available on the internet, right? So that's a passive way for an attacker to gain access, to gain a better understanding of your APIs. An active way will be to actually make requests to that API, right? That will be an active way. Uh, the information from your perspective is also under inventory, under Recon. So in here you will see all the different domains and subdomains that have been discovered in a tree-like structure, and along with metadata. Okay, so this is the result of uh, discovering domains and subdomains. And finally, if you have any recon findings, you're going to see them under the recon subheading and then the individual findings. Okay, that's where you will see them. And again, recon in the training environments is turned off by default because operating a recon service is expensive. Okay, we do not want to make use of training environments like costing us gazillions of dollars because of recon service. So that's why it's turned off. Back to the slides very quickly. We'll talk a little bit about posture. There's two types of postures: traffic application based and environment based. We'll start with traffic application based. These are the findings that relate to the application, to the traffic, and they could be because we are returning forbidden data when we shouldn't be returning. For example, we're returning a tax ID, a social security number, or whatever tax ID you have in your countries when we have an error response. So we send the request, the response for that request is in error, 400, 500, and we also send forbidden data like a tax ID. Okay. I understand we shouldn't be doing this, and you shouldn't be doing this, but it still happens. That's why we have this type of application level forbidden data. And again, I've seen them being called traffic based or application based. I use either one of these terminologies in order to refer to it. Traffic posture findings, right? Application posture findings, and so on. And then we have the environment based posture findings. This is where we're able to identify misconfiguration simply because we have enough permission to identify your environments, your network, right? And we want to keep doing this. We want to keep doing this periodically because changes to our infrastructure happens all the time, right? Or happens often. So we want to perform these scans periodically in order to identify new misconfigurations. In addition to that, all the environment-based posture findings can be they have an automated detection of fixing them, right? So what do I mean by that? I mean we scan, we identify a posture finding, an environment posture finding. We keep scanning, we keep scanning, we keep scanning. If your sysadmins, I suspect sysadmins, will fix that posture finding, well, the next scan we will detect it and we're going to mark the finding automatically as being resolved. Okay, as being resolved. Just to give you a little bit more information on this, if I go back to my findings and I clean up, let me clean up the filter because by default the findings are only showing the in progress and the open findings. So if I select, I'm going to see a finding API server using a weak cipher suite has been resolved. This is primarily because the no-name platform detected that the fix was introduced and it tagged the finding as being resolved automatically. There's no use from your end, right? No need to act on your end from the user's perspective, okay? From the no-name platform operator's perspective, okay? So this is also, not this one, this one. This is also an environment-based finding. These are still open. What you can do from a user perspective is come in here and set it to resolve not verified. Right? Number one, resolved is not present, right? The resolved is not present. So you can come in here, you can say resolved not verified. If you tag this as resolved not verified, you're going to have to give a reason. And you also given an explanation that this finding supports automatic resolution, which means that the no-name platform must confirm from the traffic or the configuration, right? All those end graphs pulling in the infrastructure, whether this has been resolved, right? Once we verify that this finding has been resolved, then we're going to move the status from resolved not verified to resolved, right? So you have been warned. And again, you want to use, and you may be wondering now, why would I want to use this resolve not verified? Because you do not want to wait until the no-name platform detects it. Right? This may take a few hours, this may take a few days, right? And again, it all depends on how fast your guys are, right? The sysadmins. And of course, depends how often the no-name platform is configured to scan, right? By default, it's done every 10 hours, right? For environment-based misconfigurations, right? But that's a default value. It may have changed for your environment. Right. Now, if you want to find what's the actual value, you need to talk to one of us, right? Your contact, your CS contact, and so on. And they should tell you. They should be able to track it down. All right, cool. Let's go back to the slides. All right, so that's posture. Let's go to the last one, runtime. So we have two types of runtime incidents. The WAF-like, pattern-based, SQL injections, cross-site scripting, command injection, and so on. And then you have the AI-based anomaly detection. Okay, AI-based anomaly detection. So let's start with a WAF-like pattern-based. And you may be wondering, well, I already have WAFs. Why do I need this? I've seen sometimes the WAFs missing one of these. Maybe not a SQL injection because it's so well known, right? But I've seen one of these like being detected by the no-name platform, missed by the WAF, and so on. I've seen instances of that. Again, our customers wanted us to include this, so we included them as a fallback scenario, right? As a fallback detection mechanism. And then we have the AI-based anomaly detection where we build data science models. And again, you may be wondering, what the heck is a data science model? Well, it's the marriage of statistics with machine learning. That's what it is. Right? That's what data science is. I remember back in my day when I was doing a minor in commerce, we used to call them decision science. It was business statistics in my end, but that's what they were, statistics, in order to make informed decisions, right? So data science includes machine learning. Machine learning is used in order to learn the behavior, capture that behavior inside statistical models, and that gives us the ability to detect abnormal, anomalous behavior, right? The other thing I want to mention, all the WAF-like pattern-based, I forgot about this, and I'll show it to you. They're all going to be packaged. You're going to find them, of course, under runtime, incidents. All of them, all the WAF-like, they will be packaged inside an API input validation attack. Right? And if I select one of these, you will see that the attack type is a command injection in this particular case. Okay. Alrighty. Slides. Slideshow. Okay, cool. Oh, the last thing is the data customer runtime. They based upon live traffic. Okay. The other ones are proactive, and in fact, that's a good place to move into the second slide, where we're talking about the differences between the different types of security vulnerabilities. Data custom and runtime, they're both reactive. They of course depend upon live traffic. And posture and recon, these are proactive in order to preempt potential future attack, right? And that's the main difference between these two sets. Reactive, you're under attack or a potential attack. Proactive, you may be under attack in the future, right? It's a vulnerability, it needs to be fixed, right? But it's not something that must be done right now. Especially with runtime and data custom, you probably want to deal with it ASAP. All right, so data custom, posture and recon, they're deterministic. That means they're always true positive. That's a loaded statement, I know. I will tell you right now that data custom, they are always true positives because after all, you are the ones who define them, right? So you are the ones who create them. So if you messed up, in their definition. It has nothing to do with an on platform. It has to do with you creating a bad definition, right? Or us, the users, creating a bad definition. So this is always true positive. This is less so when it comes to posture and recon. Posture, deterministic. I've seen some of those that are benign. That means they're no longer an issue for a particular customer. But generally speaking, you are presented with fairly indisputable evidence when you have a posture or a recon finding indicating that there is a problem. Okay, so you give in links, hey, click there, and so on. I'll show you a posture one. Right, if I go back to findings, here's my different postures. So the one that says, yeah, let's go here. Internet-facing host supports weak TLS cipher suites. So if I selected, I will be told, hey, this is the host. It supports weak TLS cipher suites. And if I go to the evidence, I'm going to be giving a list of all the different cipher suites that we detected, that on a platform has detected, right? And these are weak cipher suites. Okay. So, and again, if you know anything about cipher suites, we'll talk about it in the near future. You got to use either the secure or the recommended, as opposed weak and insecure. Right? Quick illustration of this slideshow. The different components that are responsible for detecting the corresponding incident and finding. For data, you have the traffic and the user interface. The user interface because you define it, and then the live traffic in order to compare it. Runtime, it's always traffic. Posture, we can get it from sometimes from traffic. For application based or environment based, we need to scan and identify your environment. And finally, for recon, recon service, and we need to do the configuration ourselves. That means add those domains. Lifecycle, live online. Live online, we need traffic. We need live traffic. Posture, these are periodic. We scan periodically your infrastructure, your systems, in order to identify vulnerabilities. What's a sample size? 1. A runtime, you need, I don't know, hundreds of thousands, tens of thousands, a million of requests before we learn behavior. And we'll talk about it in the near future. And finally, for posture, for traffic base, you need 1 request. Environment, you need the environment. You need enough permissions in order to give the non-name platform access, give the non-name platform visibility to your environment, right? So we can build the end graph and all the good stuff. And finally, recon, it's solely environment based. All right. So these are the main attributes of a security vulnerability in the non-name platform. Okay. And I'm going to start with these hyperparameters. What the heck is a hyperparameter? So I'm going to click. This is a hyperlink. There we go. In machine learning, a hyperparameter is a parameter such as a learning rate or a choice of optimizer which specifies details of the learning process. Right? Details of the learning process. So a hyperparameter controls the learning process, in other words. That's what it does. Okay? It's very important. So this is data science stuff. Okay. So its values control the learning process, and some of the most common or the most common hyperparameters that you will see is the number of API users, number of distinct API users, and time since API discovery. So you need time. It's in the days though, right? It's in the days. Hyperparameters applies for runtime incidents exclusively, right? The I can't remember now. What did I call it? The AI-based anomaly detection runtime incidents. Right? That's where they apply. It doesn't apply to the WAF-like incidents. It doesn't apply to any of the findings. Right? Only incidents. So, then what happened? It's going to give us a description of the security vulnerability and an explanation of the conditions or triggers that raised it. Right? Always consult what happened. This is where you're going to see the information specific to your finding to your incidents and so on. Severity, uh, info, low, medium, high, critical, right? And depends, and this one depends which severity the no-name platform is going to set it to depends upon the context, the condition that determine the severity of an issue, right? The context. OWASP, there's always an OWASP category associated with every single security vulnerability the no-name platform is able to detect. Because OWASP is a well-known quantity, categorizing every single security vulnerability with the OWASP category gives more insights to those of us who are familiar with the OWASP API Security Top 10. Okay. The issue subject matter. It's not always. It's not present explicitly, but it's inferred. It's inferred. Okay. And it's important because it gives you some more context details. And what you should do is usually a cookie cutter answer on what you need to do in order to remediate, to fix that particular vulnerability. Right? And with this, we have concluded this fairly long section. Okay, this is a pretty long section. Okay. Talk to you in the next.